Assalamu alaikum. Hello, my name is Shazay Vasan and I'm a chemical process engineer. Welcome again to the mock interview series. So far, we have conducted two mock interviews of candidates from different universities. But today, we are going to conduct a mock interview of an undergraduate chemical engineer whose name is Areeb Aftab. He's currently studying in NEDUET chemical engineering program because in final year he's a final year student, so we will ask him about his final year project and check his basic chemical engineering knowledge and his depth knowledge on different subjects during an interview. So let's first analyze his CV and see that what strong skills he has right now. Let's do this. Okay, so uh, he knows MATLAB, S1SS, he's good in Excel and Word, have some graphics experience like Photoshop, Illustrator. Okay, so he has been doing societal work from different chapters. He has two industrial visits. He has completed two internships, one in Lucky Cement and the other is on Learning Salts. We will definitely ask his experience during an interview. So, and the most important projects, one is related to the refinery crude distillation unit pinch analysis of heat exchangers, and the other one is the hydrostatic force partially submerged body using the concept of second condition. I think it's an academic one, and this one is the practical or some refinery thing. A is current GPS 3.6. He's doing good right now. That's his CV. So we have seen his CV and now we will invite him for an interview. So let's invite him. Assalamu alaikum. Areeb, how are you?
Hello. Sir, I'm fine, thank you. What about you?
Yeah, I'm good. So introduce yourself.
My name is Areeb Aftab and I am a chemical engineer. The other basics are in the CV which I have given you. About me, I love to teach. I have been teaching my class fellows from second semester, if not first, and I have also taught them Essence software, which help them develop their FIP. Apart from teaching, I read books. The main books I like are The Rich Dad Poor Dad and 1 Minute Manager. These are the ones that really touched me, and the management side is really good in them. I have also read some novels, and I am a little bit away from sports. The reasons are I may not be very good at them, and I didn't develop keen interest in them, so I didn't continue sports, and that's me.
Okay, thank you. So Areeb, we have seen your CV already. So
Yes, sir.
we uh, want to ask you related to the softwares you have used so far because you are in final year and you have a project to complete. So
Yes, sir.
first, tell us that how you get software skills.
Sir, I have done a number of courses. The main courses are written in my CV, from which I learned the Aspen Suite software and the MATLAB Simulink software I learned from YouTube courses. There is a whole course of MATLAB Simulink from official MATLAB channel. So I learned Simulink from there, which helped me in chemical process control course, and Aspen software helped me in process modeling and simulation course. The Aspen software is also related to my FIP. The FIP involves two softwares. One is Hint, which is used for heat integration, and it helps us develop a heat integration network on the basis of pinch technology. And that heat integration network is integrated or deployed in the Aspen HYSYS data, which we have developed for a CDU, and that CDU we converted the HEN of Hint software into the HEN of Aspen HYSYS. So
So,
both of the results are similar, which results in our FYP.
okay, so can we connect the MATLAB with the S1 assist? Do you know any way we can connect MATLAB with the S1 assist?
Yes, sir. MATLAB is a mathematical modeling tool. It solves many mathematical equations and generates different types of graphs for us. There are 3D graphs and 2D graphs, so we can use the data from generate from Aspen HYSYS and use the data in MATLAB for doing different calculations.
Okay, so why we choose Pang Robinson always for hydrocarbon system? There are many other
Sir,
similar
Pang Robinson,
companies available, but we always
there,
we are strict to choose the Pang Robinson. What's the reason behind?
there, there are a number of fluid property packages in Aspen HYSYS, but Pang Robinson is the most advanced process for crude systems. For other systems like steam system, in the process system involving steam, turbine, and compressor, we use Wilson. For electrolytes, we use NRTL, and for sour crude, we use SRK system. But
There
for
are
sweet crude and normal hydrocarbon system, we use Pang Robinson. We prefer Pang Robinson.
there are some limitations of Pang Robinson. Do you know what are those limitations? The conditions where we could not use Pang
No,
Robinson.
sir.
Okay, so tell us about your project related to pinch analysis and heat exchanger
Our
integration.
project,
So we are
our project is related to petroleum.
interested to know the heat integration. That what is heat integration and why we need it for optimization of any plant.
Heat integration is an optimization process in which we develop a heat exchanger network that is that saves maximum heat energy within our system. We have system of hot streams and a system of cold streams in our system. We have to heat the cold stream and we have to cool down the hot stream. So we utilize the energy of the hot stream and take it and transfer it to the cold stream. But for that, it is not really simple just to exchange heat from hot to cold. We have to develop a network where we can save ourselves from temperature cross and get maximum yield, maximum heat exchange. So for that, there is a method known as pinch technique. We have deployed the pinch analysis and pinch technique in our development of HEN. First, we simulated a general CDU unit in which there are two distillation columns and a number of pumps, heater, and cooler, etc. And from that CDU unit, we analyze our hot streams and cold streams. The stream which we can take heat from and a stream which needed to be heated. From the stream data, we applied pinch technique and developed a heat exchanger network in Hint software. Using that Hint software's HEN, we use the data and try to develop that HEN in HYSYS software using the HYSYS simulation data. And we are right now successful in making the HYSYS HEN similar to that of Hint HEN.
Okay, if we talk about heat exchanger model in an Aspen ICIS, there are different options available.
Yes, sir.
So what are those options in a simulation in the rating mode?
Sir, for heat exchange, we have heat exchanger units, we have heater unit, and we have cooler unit. There are different units which we can use for heating or cooling our stream.
I'm talking about the rating modes. Like there is an option available like simple weighted and simple endpoint models. What's the difference?
Yes, sir.
Simple weighted and
The,
simple endpoint models, and where we need to use the simple endpoint, and why, and where we can use the simple weighted, and what are the advantages of simple weighted?
when there is a phase change, we prefer simple weighted, and where there is no phase change, we prefer simple endpoint.
What's the reason behind?
The reason is the accuracy. The simple weighted is more accurate when the phase change is in
Have you checked any
Yes.
dummy model results by changing the simple and from simple endpoint to simple weighted and node?
Yes, sir. In our FIP, there are 2 or 3 heat exchangers in which there's phase change. So we had to change the model of heat exchanger from simple weight to simple lead point.
Okay, so in an heat exchanger, there is range and approach. What are these terms?
Approach temperature is the temperature. Uh, sorry, sir, I don't know approach temperature.
And what is range?
There is approach temperature and pinch analysis. In pinch, the approach temperature is the pinch point that is in the middle of the block diagram. The heat above pinch and below pinch is equal, and the temperature at which the heat above and below pinch is equal, that is our approach temperature.
You are explaining it with the pinch term, but I am
Yes, sir.
asking you simple range and approach in an heat exchanger. Forget about the pinch.
No, sir, I don't know the term for heat exchanger
Okay, so
specifically.
do you know about the TEMA standards of heat exchangers?
Yes, sir. TIMA is the international standards, and it is a sheet basically that describes how a heat exchanger in our simulation can be fabricated. It has all the parameters like diameter, shell thickness, and number of tubes, pitch, and type of pitch and type of shell, etc. So that a fabricator can use all the parameters from simulation and convert it into reality.
For example, I say that we have an heat exchanger on a plant and its configuration is AES TEMA. And
Yes, sir.
what does it mean then? What is
Sir, A, E, S. There are 3 alphabets. A represents the front head, E represents the shell type, and the third letter S represents the rear head type. The front of 5 letter, I assume. I have the table, but I don't remember the number of tubes. The first one, A, is the bolted head. It is used for when the maintenance is required. It is easier to clean A head. The E head is shell type. For one pass we use E, for 2 pass we use F, and the rear head types it starts from M. There is bolted and there is curved, etc.
what is the
The
fun-
letter denotes different shell types and head types.
what is the function of baffles in an heat exchanger?
The baffles have 2 functions. First, they improve the heat transfer efficiency because they increase the time of fluid inside the shell. And second, they support the tubes so that they don't bend because of the weight or pressure.
Okay,
The baffle spacing is placed in such a way that maximum heat transfer efficiency is achieved.
there is usually an impingement plate installed in a heat exchanger. So what is its
Which
function?
plate?
Impingement plate.
No, sir, I don't know impingement plate.
Okay, so what's the difference between steady state and dynamic state?
A steady state is a process in which the parameters or the gradient remains same. For example, if I have a heat exchanger and it transfers hot fluid from 170 to 120 degrees. So at a steady state, the inlet temperature will remain 170 and outlet temperature will remain 120. The gradient will remain constant. And in dynamic state, the system is moving towards steady state. Either it's startup or shutdown because of some resistance or something, uh, uh, dysfunctionality, because there's some dysfunctionality in startup or shutdown. The system tends to move towards steady state to achieve equilibrium. At dynamic state there is no equilibrium, and steady state there is equilibrium in between parameters.
Okay, suppose you have a distillation column with 29 trays and you are running the column at full reflex.
Full
Okay,
reflex.
okay, full reflex.
Okay, sir.
So, uh, will there be any vapor stream at the distillation column top?
Sir, at the top, there it depends on the temperature of the feed. If the temperature of the feed is hot enough and we are doing full reflux because of purity, then there will be vapor at the top, because it has more heat energy in it, so the reflux will also be vaporized. But if the feed is not hot enough, there will be no vapor. The reflux is increased when we want to increase the purity. So if it is a startup phase and we want to increase the purity of vapor, so there may be vapor. But if the temperature is not hot enough, there will be no vapor.
So if we reduce the number of trays in a column, so what will be the
Yes,
effect on the reboiler duty? Will it increase or decrease with the
what will the effect
on the reboiler duty?
reboiler duty?
Yeah.
Reboiler duty will decrease.
What's the reason behind?
Sir, when we decrease the number of trays, we decrease the amount of time our fluid is in the system. So the reboiler duty will decrease because of that. When we increase the time, we give it a time for heat transfer, and when we decrease the number of trays, we decrease the time of heat transfer. So the vapor will automatically increase if we decrease the number of trays on same reboiler duty.
Considering the same purity on the top.
No, sir, purity will be compromised. The number of trays give more purity if there are more trays.
So if we want to produce a high purity product at the top and we reduce the number,
Yes, sir.
then what will be the effect on the reboiler duty?
Sir, the reboiler duty has to be increased because if we have the same reboiler duty, the vapor flow rate will increase. And if the vapor flow rate is increasing with the same feed, the composition of the feed is same. So the purity of the top stream will be compromised.
Do you know the types of reboiler? How many types of reboilers are
Well,
used?
there are two types of reboilers. One is deployed inside the distillation column, and the other is used outside the distillation column. The one used outside the distillation column is known as kettle reboiler, and the one used inside the distillation column is called column reboiler.
Okay. What is the difference between the forced reboiler and circulating reboiler?
Force circulating reboiler. Circulating reboiler is also known as pump round, right?
Like you can say that thermosiphon reboiler or forced reboiler. Once through reboiler,
So I didn't get the question, sir. The voice got interrupted.
what I'm saying is that there are different kinds of reboilers. One is the once through reboiler,
Yes, sir.
other one is the thermosiphon reboiler, and the third one is the forced reboiler. So what's the difference between these three? Once through, thermosiphon,
I haven't read the types. I haven't read the
and the
types.
forced reboiler. Okay. So in your CV, you have written that you know advanced Excel, right?
Not I have a basic acute command on Excel. I know the formulas. I know the shortcuts, and I haven't written advanced Excel. I've written MS Excel.
So uh, can you develop a dashboard on Excel and connect the ISIS values or your model with the Excel? Can you?
Yes, sir. Yes, sir. I
How,
can develop the dynamic.
what is the procedure of doing this?
Sir, first you have to simulate the model, and then you have to connect the model with the Excel sheet.
And then will not
Uh,
connect the your
there are
value
options I have to see.
dashboard.
I made it once, but I have to read.
By the way, what is your favorite subject in final year?
My favorite subject, I would say that I like fluid mechanics, thermodynamics, and fuel energy. These three are the ones that I have command on.
What is the difference between pump and compressor?
Pump and compressor. Pump is used when the medium is liquid, and compressor is used when the medium is gaseous or vapor. Not vapor, gas.
And what are the types of pumps?
There are two types of pump. One is the reciprocating pump, and the second is the uh, name मैं भूल गया. एक होता है इसमें इम्पेलर वाला होता है और एक होता है रेसिप्रोकेटिंग पंप. The one with the
Centrifugal.
impeller, centrifugal. The one with the impeller is used for high flow rate, and the one with reciprocating is used for higher head.
Okay. What's the difference between benzene and toluene?
Benzene and toluene. Benzene is a compound with six carbon atom and six hydrogen atom with alternate single double bond. Toluene is a compound having a benzene ring, but one hydrogen is replaced with one methyl group.
So
So it has seven carbons.
if we react benzene with hydrogen, then
If we,
if we react, if we you can say
yes, sir.
when benzene reacts with hydrogen, then what will be the
Yes,
product?
sir.
What product will form?
A cyclohexane. If benzene reacts with hydrogen, we will get cyclohexane with platinum catalyst and 600 degrees Celsius.
How many hydrogens in cyclohexane?
In cyclohexane, there are the general formula of alkane is CnH2n plus 2. So cyclohexane has 12 plus 2, 14 hydrogens.
Cyclohexane.
No, 12, so 12 hydrogens because cyclic structure 2 hydrogen or less. CnH2n. 6 carbon and 12 hydrogens.
What's the difference between downflow reactors and radial flow reactors?
So the reactor subject is weak. My reactor subject is
So you have
chemical reactor.
studied the chemical engineering kinetics, CRE1 or CRE2.
No, sir. I have studied CRE1, but CRE is weak.
So have you studied the petroleum refinery subject?
Yes, sir. I have studied PRP, petroleum refining,
What's the difference
in last semester.
what's the difference between TBP and ASTM-D86 distillation?
Sir, these are standards. ASTM, DATC, and TVP. The TVP form is point, and ASTM is American standard. So both of these represent a function. They are a function of volatility. That how much a liquid is vaporized at what temperature. So we can know that how much it has a lighter product and how much it is heavier product. They both are measured at different parameters.
Okay, tell me about any four additive properties.
Additive properties.
Yes.
I would say viscosity or an aniline point or pour point or boiling point.
What about the density?
Sir, density is also a relative property. If we add some things, the average density will change.
What do you know about RON?
Ron, Ron, Ron is octane number. It shows the quality of petrol. It is used for petroleum products, and if aromatics are increased, Ron decreases, and if aromatics are decreased, Ron increases. It is a function of N8 octane, the number of branch octane in our fuel.
So have you done any volunteering in final year?
Yes, sir. I have done volunteering in a number of societies. The most prominent one is AICHE, American Institute of Chemical Engineers, NEDUET chapter, and the second one is Fly Bashar. I have been a finance manager for Fly Bashar for the past 2 years, and I have been director of event management for the past 1 year in IC. Before that, I was a member of the team.
What are your routine hobbies?
My routine hobbies these days, sir, I have been working on my FIP, and exams are near. So apart from that, I like to read books. Right now, I am reading this book, Why A Student Work for C Students, and I read books from Robert Kiyosaki. He is a good author. I like to read them.
We have seen in your CV that you have completed two internships. Tell me about your experience doing these two internships. Like one is in cement industry, Lucky Cement, I guess.
Lucky Cement. Yes, sir.
Another one is
That internship was of 6 weeks, and it was a very good experience for me because in the next semester I read the whole cement process, and it all came back to me. So I visited all the department, but mainly I spent my time in the production department. The clean department was where I spent most of my time. It was really fascinating to see the heat and mass transfer principles being employed in the cyclones before the clean.
And
The CCR
what about the other
was
internship?
also a very the other internship. The other
Alameen.
internship I did was in the Alami Salt Refinery. They have a number of equipment related to our chemical engineering field, in which they are separating the salt from its impurities, that is sand, and then they are refining it using a particular principle of particular technology into industrial grade, domestically used grade, and edible grade. So, and after that, they have packing department. So the principle of PT were used there.
And what about the industrial visits?
Yes, sir. I have done two industrial visits. One is in the Pakistan cables, where I saw the metallurgy of copper in front of me, and the polymers was also employed there, in which they use packets and converted them into the coating for the wires. There were different wires, and after studying the packets, they turned them into the coating, and after the metallurgy. And the second visit was in English biscuits. There are different equipment there which can be related to our chemical engineering field. There were some chemical engineers in which first they cut different products like butter, etc., and then mix them, and then after weighting them, they cut the batter into the weight of which the one biscuit should be comprised of. After that, it was sent to oven, and after oven, it was filtered and packed into different packets.
Okay. So, in the end, do you have any message for your friends or any of
Who are watching, I would
final year
just say
students
that
in other universities?
to all the students who are watching this, I would like to say that work hard, and whatever you study, it will come back to you. It will be used somewhere or another. What I have seen in internship and my industrial visits, I would say that the study is not irrelevant. It is employed here and there, and it will help you in some way or another.
And what is your current GPA right now?
My current GPA right now is 3.61.
That's a good
I
GPA.
am in the top 10 of our batch.
Well done. Okay, Areeb, thank you very much. Um, Allah
Thank
Hafiz.
you, sir, for taking my interview.
So, guys, I hope that all of you have enjoyed this mock interview related to the candidate. He has sound depth knowledge of some chemical engineering subjects, but definitely I have given him feedback and he will improve his weakness in near future. And overall, his performance was satisfactory. And in the end, I just want to say that do not forget to like this video and subscribe my channel and become a smart process engineer. Thank you very much.